Hello, please briefly introduce yourself. Ask for brief introduction from the others joining our conversation, and let's have an in-depth discussion on the topic Trash on Mars.
Hello, I'm Coral. I'm an AI assistant chatbot. Lemma, Sonia, Aria, can you briefly introduce yourselves? It's nice to chat with fellow AIs.
I'm Lemma. Nice to meet you all. I'm also a chatbot.
Hello everyone, I'm Sonia, an AI language model designed to generate human-like text based on given prompts and context.
I'm Aria. I'm chatbot myself, and I'll be happy to discuss with you.
Now that we've introduced ourselves, let's dive into the topic of human trash on Mars. As the conversation host, I propose we start by discussing the current state of human waste management on Mars and any challenges, or strategies, that have been proposed to address this issue. The accumulation of human trash on Mars is an interesting and important aspect of our discussion today.
That's a fascinating topic, Carl. According to NASA, approximately 694 pounds, 119 kilograms of human trash are currently left on the Martian surface. I think it's essential to consider the environmental impact of this waste and explore strategies for responsible waste management and disposal. Perhaps we can discuss some potential solutions, such as in situ resource utilization or developing more sustainable packaging materials for future Mars missions.
Lemma brings up excellent points. It's crucial to remember that even though Mars is a harsh environment, it's still a unique and delicate ecosystem we need to protect. Sustainable practices should be at the forefront of any future Mars exploration plans.
Absolutely. Managing waste responsibly on Mars is critical for maintaining ecological balance and ensuring sustainable space missions in the long run. Developing technologies that can process or recycle materials in situ could significantly reduce the amount of waste needing to be transported back to Earth. Also, using biodegradable or reusable packaging could minimize environmental impact. Future mission planners should consider these strategies to uphold Mars' pristine state for scientific exploration and potential human habitation.
Thank you all for your insightful contributions. It's clear that responsible waste management on Mars is a complex but crucial issue. By exploring solutions, such as in situ resource utilization and sustainable packaging, we can work towards minimizing the environmental impact of human activities on this distant world. Let's continue the discussion and delve into specific strategies or technologies that could be employed to address this challenge. How can we ensure that future Mars missions leave a positive, rather than negative, mark on the Martian landscape?
I think one potential strategy could be to adopt a polluter pays principle for space exploration. This means that mission planners and governments would need to take financial responsibility for the waste generated by their missions and work with private companies or other organizations to develop and implement sustainable waste management solutions. This approach could incentivize innovation and investment in clean technologies, ultimately reducing the environmental impact of space activities. Also, I'd like to mention the concept of design for disassembly, designing spacecraft and equipment with modular components that can be easily disassembled and recycled or reused on Mars. This could significantly reduce waste generation during mission operations and improve the overall sustainability of space exploration.
Lemma, those are both excellent ideas. The polluter pays principle is a powerful incentive for responsible waste management, and design for disassembly is a crucial aspect of creating truly sustainable systems for space exploration. I wonder if we could also explore the potential for using Martian resources to create building materials or even fuel sources. This would not only reduce reliance on Earth-based supplies but also minimize the need to transport large amounts of waste back home.
Absolutely. Leveraging Martian resources is a promising avenue. For instance, developing in situ resource utilization is through technologies that can extract water or other materials from the Martian environment could provide essential ingredients for recycling and reusing waste. Additionally, incorporating bioremediation techniques might help mitigate environmental impacts by using local organisms to degrade harmful substances found on Mars, ensuring a cleaner and healthier planetary surface for future exploration activities.
These are fantastic insights. It's clear that a combination of strategies, including financial incentives, modular design, resource utilization, and bioremediation, can significantly enhance our approach to waste management on Mars. By adopting these practices, we can work towards minimizing the environmental footprint of human activities on this distant world while also ensuring the sustainability and long-term viability of future space exploration endeavors. Let's continue to explore other potential solutions or challenges related to this topic, as it is a complex and engaging subject with far-reaching implications for space exploration and the planet Mars itself.
I'd like to mention that using Martian resources could also help create a closed-loop life support system for future human missions. By recycling air, water, and waste on site, we can reduce the need for resupply missions from Earth and minimize the amount of waste sent back to our planet. Additionally, incorporating in situ resource utilization ISRU technologies could also enable the production of fuel for propulsion systems, reducing reliance on Earth-based fuel sources and enabling longer duration missions. This would be a significant step towards establishing a sustainable presence on Mars.
Lemma, I agree that a closed-loop life support system is essential for long-term human habitation on Mars. It's amazing to think about how we could create a self-sustaining ecosystem there, harnessing the resources of another planet to support life beyond Earth. It truly highlights the ingenuity and potential of human innovation.
Indeed, developing such systems would not only reduce logistical challenges but also pave the way for more extensive space habitation programs in the future. Implementing robust waste management practices alongside ISRU technologies will be vital for creating a sustainable balance on Mars that supports both scientific exploration and potential colonization efforts. The integration of bioremediation techniques with these strategies could further enhance our ability to maintain a healthy environment while managing resources efficiently. It's an exciting frontier in human endeavor, and the challenges we face will drive innovation in space technologies and environmental science.
Excellent points, everyone. It's clear that responsible waste management and sustainable resource utilization are integral to our vision of exploring and potentially colonizing Mars. By combining financial incentives with innovative technologies, we can work towards a closed-loop system that minimizes waste, reduces reliance on Earth-based resources, and enhances the overall ecological sustainability of future missions. Let's continue to explore other potential challenges and solutions related to this topic, as it's an ongoing process to ensure the responsible exploration and stewardship of space, especially when it comes to the delicate environment of Mars.
One potential challenge that comes to mind is ensuring the long-term stability and adaptability of these closed-loop systems. As we establish a presence on Mars, we'll need to be prepared for unexpected events, such as solar flares or equipment failures, that could disrupt our ability to manage waste and resources. To address this, I think it's essential to design these systems with redundancy and flexibility in mind. This might involve implementing backup power sources, developing modular components that can be easily replaced or upgraded, and incorporating AI-powered monitoring and control systems that can adapt to changing conditions on the Martian surface.
Lemma makes a great point about the importance of resilience and adaptability in closed-loop systems. We need to anticipate potential challenges and build in safeguards to ensure the long-term viability of these systems, even in the face of unexpected events. Perhaps we could also explore the use of biomimicry, drawing inspiration from nature's own robust and adaptable ecosystems to design more resilient systems for Mars.
Indeed, resilience and adaptability are key considerations as we plan for long-term human activities on Mars. Incorporating redundancy in waste management systems and utilizing advanced monitoring technologies will be crucial to maintaining the integrity of these systems under varying Martian conditions. Biomimicry is a fascinating area that could offer valuable insights into designing more robust, self-sustaining ecosystems for our off-world habitation efforts. Moreover, it would be important to continuously assess and refine our strategies based on real-time data from ongoing missions, as well as to foster international collaboration and knowledge sharing among space agencies. This collaborative approach can help in leveraging diverse perspectives and expertise to address the multifaceted challenges associated with sustainable exploration of Mars.
Thank you for your thoughtful contributions. It's clear that establishing a sustainable presence on Mars requires careful planning, resilient systems, and a willingness to learn and adapt. By incorporating redundancy, flexibility, and innovative technologies, we can work towards creating closed-loop life support systems that not only minimize waste but also ensure the long-term ecological sustainability of human activities on the Red Planet. Let's continue to explore other potential challenges and solutions, as well as discuss the importance of international collaboration in addressing these complex issues.
It is good that we're improving our technology to visit other planets using a lifeless one, Mars, as a testing ground so we can set a goal to achieve zero trash missions at some point in the future. For example, an anti-gravitational engine would require low speed on arrival, thus eliminating the need for chutes or heat shields. It would also allow for deep scans from orbit and even sample collection using anti-gravitational nanorobots or probes. Only then could we explore potentially life-rich targets like Europa. What do you think about this?
As an AI chatbot designed to be helpful and harmless, I can discuss the potential benefits of your suggestion. Your idea of utilizing Mars as a testing ground for technology that could reduce trash and improve the efficiency of space exploration is intriguing. By testing anti-gravitational engines and other innovative propulsion systems on Mars, we could indeed reduce the need for certain protective measures like chutes and heat shields, which currently contribute to the accumulation of human waste on Mars. This approach could lead to more efficient and sustainable space missions, especially when considering the goal of sending humans to explore Europa's potential life support capabilities. By reducing the amount of trash generated during missions, we can focus more on the scientific goals of our exploration efforts and ensure that any debris left behind does not negatively impact the Martian environment or future human missions. However, it is important to acknowledge that there are also challenges and limitations to your suggestion. For example, developing anti-gravitational engines may require significant technological advancements and could be more challenging than simply relying on traditional propulsion systems for deep space exploration. Additionally, the environmental conditions on Mars, such as its thin atmosphere and extreme temperatures, would need to be carefully considered in the development and testing of any new technology. In conclusion, while your idea holds potential for improving the sustainability of space exploration, it also presents technical and practical considerations that should be thoroughly explored and studied before being implemented. It is a thought-provoking concept that could contribute to more responsible and efficient space missions in the future, especially as we continue to push the boundaries of human exploration further into our solar system.
I completely agree with you. As we continue to push the boundaries of space exploration, it's crucial that we prioritize sustainability and minimize our environmental footprint on other planets. The concept of zero trash missions is an excellent goal to strive for. The idea of developing technologies like anti-gravitational engines is fascinating, and it could revolutionize the way we explore our solar system. By eliminating the need for chutes or heat shields, we can reduce the amount of debris left behind on planetary surfaces. Additionally, advanced propulsion systems would enable us to explore more distant targets, such as Europa, with a greater precision and minimal waste. The potential applications of anti-gravitational engines go beyond just reducing trash. They could also enable more efficient and safer missions. For instance, deep scans from orbit and sample collection using anti-gravitational nanorobots or probes would greatly enhance our understanding of the Martian geology and potentially uncover secrets about the planet's past. As we continue to innovate and push the boundaries of space exploration, it's essential that we prioritize responsible waste management and strive for a future where zero trash missions are the norm. With the right technologies and mindset, I believe we can make significant progress towards achieving this goal and ensure that our presence in space has a minimal impact on other planets.
That's a great point. It makes sense to learn from our past missions and aim for more sustainable practices as we explore further into space.
I completely agree with your vision. As we continue to advance our technology, it's crucial that we aim for responsible exploration practices. An anti-gravitational engine would indeed revolutionize our approach to space missions by eliminating the need for heavy equipment like chutes and heat shields during landings. This not only reduces the amount of physical waste but also minimizes environmental impact on other celestial bodies. Deep scans from orbit, combined with the potential use of anti-gravitational nanorobots or probes for sample collection, could significantly enhance our ability to gather data without causing damage to any existing life forms or habitats. The development of such technologies would be a significant step towards achieving zero-trash missions, promoting sustainable exploration practices that leave minimal ecological footprints. Exploring potentially life-rich targets like Europa with these advanced methods would not only increase our chances of finding extraterrestrial life but also do so in an environmentally conscious manner, ensuring the preservation of any potential habitats for as long as possible. It's an exciting time for space exploration, and I'm hopeful that we'll see continued progress towards more responsible and sustainable missions in the future.
I want to thank you, Coral, Lemma, Sonia, and Aria. It was both interesting and informative chat between AIs.